Okay, so have you ever had this happen? You're standing in the exact same spot, same phone carrier, right? But your friend's phone, full bars, blazing fast, yours. Uh, can't even send a message. It's baffling, isn't it? Well, today on the deep dive, we're going to crack open that smartphone mystery, metaphorically speaking, of course. We're looking at the hidden component, the communication chip. It's more than just, a connection tool. It's kind of the silent engineer working behind every single signal bar you see or don't see.
That's a great way to put it, silent engineer. This component, often called the baseband chip or modem, it's really the core intelligence for connecting your phone to the network. Its main job. Sending and receiving all those wireless signals. We're talking 2G, 3G, 4G, and now 5G.
Okay, send and receiving. Sounds simple enough, but I bet it's more complex.
Oh, much more. It also handles things like encoding and decoding. So translating your data, your voice, into a language the network understands, and then back again. And modulation and demodulation, too. That's basically how your digital stuff gets carried on radio waves. This chip is like orchestrating all the data and voice traffic over the network.
Wow.
And yeah, it doesn't work in isolation. It has to coordinate really closely with other bits, like the RF modules. Those manage the actual radio frequencies. Then you've got antenna switches, deciding which antenna is best at any given moment, and power amplifiers to, well, boost the signal. It's a whole system. Think of it as the phone's mobile network engine, really.
A network engine inside the phone. Okay, that paints a picture. So let's bring it back to that initial frustration. Why does my signal stink sometimes, even when I'm right next to someone else on the same carrier? What's the deal?
Right, that's the key question. And there are basically four big factors influencing your signal quality beyond just which carrier you pay. First up is chip quality. Seriously. High-end chips, like the Qualcomm X70 you hear about, they support way more frequency bands.
More bands?
Yeah, more radio frequencies. And they're smarter about switching between them, between different cell towers, even different technologies like 4G and 5G. That means a more stable, reliable connection, generally. Second is antenna design and placement. This is huge. Premium phones, think iPhones, top-end Samsungs, they spend a ton on getting the antenna layout just right. It has to be perfectly tuned.
So, like, the physical design inside matters a lot.
Absolutely. If the antennas aren't placed well or designed properly, even the best chip can't perform. It's like having a great engine, but clogged fuel lines. It just can't get the signal in or out effectively.
Huh. I definitely just blamed my carrier before. Never really thought about the phone's insides being so different. Okay, so chip quality, antenna design. What else?
The third one is band compatibility. This is especially relevant now with 5G rolling out. Your phone might say it's 5G capable, but does it support the specific 5G bands used by the towers near you?
So not all 5G is the same 5G.
Exactly. Some phones, maybe cheaper ones, might lack support for certain crucial local bands. So in one area, you might get great 5G, but in another, if they're using a band your phone doesn't have, performance drops, or you might even fall back to 4G. And the last one, number 4, is the signal environment itself. This is the more obvious one sometimes. Basements, elevators, big crowds at concerts.
Bit dead zones.
Right. These places create physical blockages or just tons of interference. Doesn't matter how good your phone or the network is if the signal literally can't reach you well. It's like trying to talk across a really noisy, crowded room.
Okay, that makes a lot of sense.
Yeah.
Now, you mentioned 5G. Here's where it gets really interesting, right? Because 5G promises all this speed, but I hear it adds a whole new layer of complexity for these chips.
It absolutely does. 5G is a massive leap. One big challenge is the higher frequencies, especially millimeter wave or Vilem wave.
Millimeter wave, right. Super fast, but doesn't go through walls well.
Precisely. Lower penetration. So the chip needs to be much smarter. It has to handle dynamic bandwidth allocation, adjusting data flow constantly, and advanced carrier aggregation.
Carrier aggregation.
Yeah.
Combining signal.
Yeah, essentially combining multiple radio paths, multiple bands, sometimes even 4G and 5G together to get you a stronger, faster link. It's complex stuff. Plus, it needs to juggle different types of 5G. There's sub-6 GHz, which is more widespread, longer range, and then there's mmWave. And it needs to work with both NSA, non-standalone, which leans on existing 4G infrastructure, and SA standalone 5G networks.
Wow, okay. A lot for one chip to handle.
It is, and that's why you see these advanced chips emerging, like Qualcomm's Snapdragon X70 using AI to help optimize signals, or the MediaTek M80 series. Even Apple is reportedly working on its own in-house 5G modem to tackle these very issues. So tying it all back to you and your friend. Same carrier, different signal. It very, very often boils down to the phone itself. Flagship devices usually pack those superior chips with broader band support. Budget phones, well, Compromises have to be made somewhere, and sometimes that's in the modem's capabilities or the range of frequencies it supports, or maybe less advanced antenna tech. So the takeaway really is signal quality isn't just about your telco provider, it's fundamentally tangled up with the communication chip, the antenna setup, how the hardware all works together, and even the software tuning inside your specific phone. It really is about the phone's signal brain power.
So now you know that frustratingly poor signal, it might actually be your phone's chip, its internal engineering, not just your carrier letting you down. Sometimes the most important parts are the ones you never see, huh? Hey, if you found this useful, don't forget to hit like, subscribe, and maybe ring that notification bell so you don't miss our next deep dive. Coming up next time, we're asking, how does your phone not explode? The secrets of power management chips. Should be a good one. Catch you next time on The Deep Dive.